All right, so we're back at Build 2017, and we're in the C++ section, which is definitely rock and roll.
Yeah.
Look at this panel, man. So STL, a.k.a. Stefan Tilaoue, the great Kenny Kerr, you know him from Modern.h, now works at Microsoft, C++ WinRT. Marian Luperu, who's the leader on the Visual C++ team. He's also going to do a demo because he's had a great talk here and they've done some good features in the product. And of course, Gabriel Dos Reis, you know him. He's on the standards committee.
Yep.
He's also done some really interesting work, is doing interesting work with modules and some other things as his day job as an engineer on their team. So we don't have a lot of time. We want to get a lot of questions, ask them. So we're going to begin with sort of the product stuff first.
All right.
Marian, give us the demo and give us a few things that you think are
Absolutely.
important.
So I had a great time at Build so far. I've been talking with a lot of customers. I've seen a lot of excitement. Not all the demos that I wanted to do in my talk yesterday fitted in. So
Okay.
I have one more. It's got fresh bits from the developer that I got this morning.
Excellent.
And overall, I think the 2017 release is a very significant release. It's got a lot of improvements when it comes to C++ development. One thing that thrills customers when I talk with them today is that, well, we can finally install C++ only Visual Studio. So that's with a revamped installation experience.
I like it.
Yeah.
I always summarize it to customers as the installer was completely rewritten and does not suck now. Like, I swear.
Right. You can actually install it under 12 minutes, full C++ desktop workload if you have like a good computer and a good connection.
Yep.
We got a lot of performance improvements in there, productivity, full functionality there in edit, build, debug cycle. Every section has been improved. One of the big things that I want to demo today is the new open folder functionality we added. This is for customers that don't already have Visual Studio projects and solutions, and they want to try Visual Studio. They want to take advantage of this inner loop and all the productivity improvements we're making. Now, basically, I'm ready to tell them that they're welcome to come. It's very easy.
Great.
And I'll just switch to the demo. So what I have here is a MinGW shell, and you can tell that by the fact that the switches are not backwards. So I have this WX form builder project, which it has some very clear instructions on how to get it to build under MSys and under MinGW. And I already did that, so I have it here in my output folder, and I'll really quickly show it to you how it works. So this is a designer for UI, and then it generates the code for you. But what I'm going to do next is, let's say I want to edit the code for such a project. Before that, I will probably use an editor, but right now what I can do is devenv dot, and what this will do will just load this folder inside Visual Studio.
Nice.
And the moment this happens, as soon as the Visual Studio Solution Explorer pops up, you can start editing code already.
Great.
Now, of course, we have defaults. We default to the Windows IntelliSense, and we expect the Windows build and Windows debugger. So there's a bit more configuration that you need to do to make MinGW work, but it is certainly possible. So what I have here is the build log from my previous build, and it's a detailed one. I clicked the wrong button. So this one. Now if I go really quickly to the main GUI, this is the command line that is used to build main GUI. So what I did, I copy-paste this, and I went to Project, Edit Settings, CPP Properties.
Okay.
And this is what configures the IntelliSense for the whole project. So I pasted in this command line over here. And that's all I had to do to go to the main GUI. And now you can see that I have full semantic IntelliSense, browsing, navigation, all the productivity features that are available in Visual Studio are also available for this
And
project.
you're targeting a different runtime.
Yeah, and there's no Visual Studio projects involved in this one.
Amazing.
Really quickly, there's a squiggle over here, so let me go to definition over here. You see boost headers are missing. So what I'll do really quickly, what happens is the boost headers are installed in the default include path of GCC. So Visual Studio has no way of knowing what that include path is. So I'll write this long command here. By the way, it's GCC -WP that lists all the default includes for MinGW. So I'll do copy and paste here. I'll go back to my settings file, and I'll add the include path over here. And there will be some editing gymnastic here, so bear with me.
The include path JavaScript object. JSON's eating the world, man.
Yes. it's a very simple file to edit. So I'll click Save.
Uh-huh.
And if I go back to my main GUI, you see that the squiggle is gone. So
Great.
now Visual Studio knows about the default includes inside MinGW as well. Really quickly, I can also, like, if I want to share this project now with someone else in my team, I don't have to hard code paths. I can go to use an environment variable that is coming from the MinGW path, which is MinGW prefix, which evaluates the same path. So someone else that wants to install MinGW somewhere completely random, they could actually take a benefit from my configuration for Visual Studio. Now that's one step, and you can bite as much as you can chew with OpenFolder, because you can move to just make IntelliSense work, but you can also make build work, and I did that already here. Let me right-click on the main GUI and say Configure Tasks. And I have a task here, so every time I click Configure Task, a new one gets created, but I have it already configured, and it's a build task. And what it does is called CMD with 2 arguments, make and config debug. So basically, I'm following, going back to my page here, I'm following the instructions on how to actually build this project. I'm building debug, obviously. So now
you're still using GNU Make to build the stuff, right?
Absolutely.
Okay. So I never thought I would live to see the day. This is really impressive.
Because I said it's a context type build, I can just hit Control-Shift-B, and you see the build running. And it was an up-to-date check. Basically, the incremental build works just great. I didn't have to build anything. One last thing we need to do. Wouldn't it be nice if the debugger will also work?
Sure.
Right. So to do that, I'll just right-click here and say Debug and Launch Settings. Now I can get to pick. Of course, we're going to default to the Visual C++ debugger, but you can also use other types of debuggers, and one of them would be the MinGW one. So this creates a template for me of settings that I would configure specifically for MinGW. And at this point, I can just switch to, I selected the main GUI CPP file, and now I can actually debug it, but you'll see that the build runs, and the debugger is getting ready to start, and we just hit a breakpoint. And this is a MinGW binary, not a Windows binary again, so this is a different debugger getting invoked here.
Very impressive.
That's my quick demo for MinGW users. We hope that all of them will try this product. So this is coming in one of the updates really soon. So these are hot bits of the developer's machine. But we already have the IntelliSense working. Building and debugging will come in post 15.3 updates. So
and this all runs natively. There's no MS Build. There's no VCX Proj.
Correct.
That's great.
Super impressive.
And as part of getting IntelliSense working, is the EDG front end used for IntelliSense going to be set into I'm going to imitate GCC mode when it's doing this? The way
That's
it can
a very
imitate
good point.
Clang?
Yes, and I kind of brushed really quickly over that. There's the IntelliSense mode in here that actually can configure the EDG mode in which we want IntelliSense to work. And we have a full list of IntelliSense modes that you can pick off.
Okay.
And you can pick the closest you want to. Of course, MSVC is one. And for this demo, I picked Clang mode.
Okay, because Clang is pretty close to GCC.
It is pretty close to GCC,
okay.
Yes.
Nice, man.
Impressive. That's my demo.
Okay. Impressive. So questions. There's people in the audience. I'm sure they want to ask questions. Looks like we're waiting to get some stuff set up. Until then, I think that's an amazing story.
Yeah.
Amazing news for people who want to use a different compiler, but want to use Visual Studio as their IDE experience to get all the goodness, debugger and whatnot. So what I want to do now, since we have a short amount of time, we have questions.
Like it.
To all panelists, let's say you have a year, a small team, and enough funding. What's the one thing you'd want to spend your time on to further C++? To all panelists.
Further the C++ language?
C++, the tool chain?
Okay, in general, yeah.
Yeah, not just necessarily the language, but it's a tool set. Maybe the linker needs to get better. So
I'd probably say concepts would be the priority. I know that there's many people on the committee working on concepts both in the core language and the standard library, including like Casey Carter, one of our library devs, who's been working on what a conceptified STL would look like. I think that is going to be the direction of C++ for the next decade or two. And getting a head start on that would be very cool. We've already started implementing concepts in MSVC. John Caves has been working on that. But with an extra, year to work on it, I definitely put that to concepts. Because I want to use it in the STL.
Yeah, for me, I would say not so much new work to be done, but it would be great if we can get coroutines and also modules, but specifically coroutines into the standard. We've taken a big bet on coroutines as a way of doing async. It's an incredible implementation we have in VC today. but we need it in the standard. I want to be able to use it in more places, in Clang and everywhere else. So,
Absolutely.
Yeah.
I think you covered the standards, so I'll talk a bit about the tooling. I think one of developers spend too much time trying to build libraries and figure out the third-party dependency problem. We kind of got already started to improve that word with VC package, but if I would have that team and I would have that year to work on, that would be one of the things that I would work on. Make sure that we have a great packaging library on top of Windows such that it's very easy to bring in dependencies inside your project, being able to build them and kind of revision your project very easily as those libraries evolve as well.
Yeah.
Well, that's actually what I was going to do. So
But you have to do something different, man.
yeah, no, finish modules.
You have another
first.
team in a year.
Yeah, finish modules, of course, and do packaging. And in my view, a good packaging for C++ needs good module system. And so we're doing module as the foundation.
Yes.
And the next stage is better packaging. And we started with VC package, but it's a lot more that I would like to see in that environment.
Yeah, I think it'll be nice to see modules showing up there, yeah.
Absolutely.
good
And you
idea.
guys already have an implementation of modules that you
Oh yeah, so yeah, we released modules back in Dev 15 update 1, and we have been improving the quality ever since then, and it is fantastic. So internally we have teams adopting modules, of course. The Edge HTML team has adopted modules. They they modularize the foundation layers, and then moving their way up. Office has started exploring use of modules, and that's actually very good. So this effort is being done on a code base that's quite tough to work in, right? The Edge HTML code, because it's a lot of
So
macros.
MSHTML.dll, you're talking about the parser, or is it Trident? What? Something in Edge that parses HTML and renders it on the screen? Is that what you're saying?
So you have the memory allocator, memory protection, for example.
Yeah.
You have the fonts libraries that have
Sure.
been modularized, and so it's moving that way. Yeah.
Great. And what about C++ WinRT modules? You using any of that in your implementation?
We have experimented with using it. It does. It provides pretty incredible build performance improvements. Today, because it's header-based and the Windows API is quite large, we end up with a large set of headers, which tends to go in your PCH file. And the problem with PCH is it doesn't scale very well to such a large set of source files. And modules just handles that beautifully. So we're very excited to get that as a first-class citizen in Visual Studio with IntelliSense and everything else, so we can offer that up to developers as the premier way to do to consume C++ WinRT.
Awesome.
And one of the things we recently announced was the support for standard library, right? And
Oh
modules.
yes, that's right. So when you write C++, everybody gets to include vector IO streams.
No, not IO stream.
List and off those, and there is no better way of checking how these things working than just giving people ability to consume the standard library as modules. So to be clear, we have not actually gone through the code. When I say we, I'm looking at him. Okay. We have not actually gone through the code and put export everywhere, but we do have a technology where you can take your existing header file and will produce a metadata that allows you or your customers to consume that header as module. And so you get all the benefits of having modules, except probably some of the isolation stuff.
Yeah, it's sort of like a prototype where we're not writing our headers any differently, and in the future, when modules are completely finished, we'll go through and rewrite the STL to basically say, oh, we want to export the functions to sort.
That's right.
But we do not want to export the internal implementation helper underscore capital sort, whatever.
Yeah.
And that way, fewer symbols will be exposed to the user.
Right.
It will further increase build performance.
Yes.
And prevent users from accidentally relying on implementation details. The big problem we have right now is that because STL algorithms are all templated, they all need to be defined in headers. That's just how headers work. And as a result, if something in algorithm needs some other public function of the STL, we have no choice but to drag it in and make it available to users. Modules will allow public function 1 to use internally public function 2, but not necessarily export that to the user unless they've asked for it. And that's something I've always wanted, and only modules is making that possible.
Yeah, and so these standard library modules are, as you said, an experiment to to get an idea of where the problems are for him. So we're just doing scouting.
And also the fact that I don't need all the code that you supply today.
That's
I don't
right.
want it all.
Yeah.
I'm only using this much
Right.
of it. Don't link all the other crap in there.
Exactly, and modules just actually implement this spirit of C++. You don't pay for what you don't use.
Amen.
When you use modules, compiler brings in only the symbols that you ask for.
Great. So now you're going to be able to save electrons when you build. I love it, man. All right, we got a lot of questions. Let's just rock through these, okay?
Yeah, sure.
So starting with Nicholas, is the Visual Studio's installer still based on MSI internally? Or did you have to abandon it to get to that?
So there is a iteration of the VSIX technology that we use today to do the main bulk of the installation, but there's still MSI parts. Obviously, there's big pieces like Windows SDK and other pieces that are still MSI based. So,
Okay, so
it's
the
a mix
answer-
of both.
So it's yes and no. It's mixed.
Both, yes.
Okay, both. All right, so can I use VS to develop the Linux kernel with C-scope now? Not if Linus says anything you do with it, man. You got to be out of your mind. So, but what I mean by that is C++. I'm sorry. So, answer that question, man.
What's the question?
Can I use Visual Studio to develop a Linux kernel with C-scope now? Maybe that's directed at you because of your wonderful demo.
The open folder. If you can write C++ code in VS and build it, maybe, but I don't know. all
Yes,
the
you should have
details
asked,
and
can
the
you develop a Linux
interfaces needed.
kernel in C++? That would have been more fun. That
I
would have
wanna
been more
try
rock
it
and
first
roll.
and then say that we do or do not.
Okay, fair enough, man. Meteor Head, CMake open folder plus WSL.
So WSL support works great today in the Linux workload that we have. So with MS Build projects, there's still some work we need to do in open folder to make that work with Linux Remote. I had a very preliminary demo at my talk. Please go see my talk about building an open folder using CMake targeting Linux. The next step would be targeting Linux inside the WSL. But again, like this is coming. This is on a roadmap. Nothing yet to.
Okay.
Build bits to be able to be used.
We'll skip Victor's for now. It's not a bad question. It's kind of large. I assume the newest C++ has many improvements and taking advantage of new hardware improvements and better algorithms for optimizing the code. Has Microsoft rebuilt the Microsoft Solver Foundation library with the latest compiler to get more performance to users? You know, blah, 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 blah. Too long of a question, brother.
I don't know
But
what a
we're using our
Microsoft
own
Solver
technology to-
Foundation is, but I do know internally we're constantly asking other Microsoft teams to upgrade to the latest Visual Studio. And it's a hard problem because all these teams, they're on their own ship schedules, and it is disruptive to upgrade the entire tool set right before they ship. So like right now, I'm sure there are teams within Microsoft using VS 2015 or even earlier products to ship. But we do try to move everybody up to the latest tool set as rapidly as
So
possible.
let me ask you a question, though, right? So if I have a custom build system and I'm only interested, say, in the work that Jim Radigan and his team is doing. I want the code gen to be rock and roll. I want it to have the new vectorizers. I want it to be very efficient. What I'm doing on the front side, who cares? If I'm using Visual Studio 2015 or not, I want the back end to generate the most recent and most capable, efficient code. Is that not a possibility?
We don't do that.
Okay.
Right now, the
We
front end
don't
and the
do that
back end
anymore.
are linked.
Okay, we don't do that anymore.
Yeah.
All right, so
But the compiler has support for saying I want to use this standard of C++. now.
Yeah,
Yes.
so the
So
front
CVE
end,
latest
so the
or-
front end does have ability to let you say, oh, I want only C++ 14, 17, and so forth.
sure.
So to a degree, you have that level
Yeah.
of isolation
Yeah.
where you can say, well, I don't want to go quite that far with C++ just
Yeah.
yet.
Yeah.
Sure.
And
What
it
we-
helps
but
to
I-
get you to the next compiler more easily.
what we stopped doing is
Especially the back-end compiler.
Yeah.
I don't
What
care
we-
about the front-end compiler.
what we stopped doing is mismatching the front end and back end, and
And that's not a good idea. I understand.
It's a lot of headache.
Okay, fair enough. All right, so Stephen PSA, what would you say to convince a C# but ex C++ developer to persuade her to switch back to C++? In a nutshell. Hey, look, you good to answer
no
that
more
question.
new and deletes.
So I'm a C++ student for the 80s.
17, for example,
Yeah.
you get this thing we call structure binding, which allows you, if you're going to request a resource, which may fail, you can actually return multiple values, saying, this is the handle in case of success, or I fail, this is why. And with that, you chain that with the ability to test. So usually you have a declaration, and you want to test whether the operation succeeded. You can test that directly in an if statement. please try to acquire this resource. Did I succeed? And then you write what matters. That simplifies error handling and how you write code. It makes fantastic, beautiful. Productivity goes up.
Okay.
Now soon we'll get modules and concepts.
Okay.
So concepts are these things, that some kind of type system for template that allows you to state at very abstract level, like we'll do for interfaces, what are your requirements on algorithm, and you'll make that man very happy.
Sure.
Right.
And has the potential to improve diagnostics as
That's
well.
right.
One of the big complaints with CS Plus is, the template errors are incomprehensible. And concepts will allow us to say things like, hey, you called sort with the wrong kind of iterator,
Yeah, that's
which is
right.
something we just can't communicate to the front end right now.
So that's on language side. On library side, we have a lot of goodies, and I will give you a list. We have file system gets now into the standard. You have foundational types like variants and union variants, so that you don't write your own next unions and shoot yourself in the foot. Now you have something that's completely type safe. You have any that allows you to truck in information of all types you want, right?
And we've got string view
Yes.
for convenient passing of strings through interfaces.
But if I'm coming from C# world, because I left C++ world because
Right.
it was say 2003.
Yeah, so I think at the heart of the question is this idea that C++ is too complicated. It gives me perf, but it's too much work. I'm going to go to C# because I'm going to be more productive there. But modern C++ now gets you that same level of productivity in the language that gives you also gives you the performance.
That's right.
So you don't have to sacrifice. Well, is it perf I want or productivity? You can have them both with modern C++.
Yep.
And we've highlighted that with C++ 1.0T, with the STL, and with all these libraries now. It's productivity in the language itself, but also the libraries that now can come around that and support the developer in getting things done quickly.
Yep. It's true. And a lot of your code can actually look like C# code. I mean, not all of your code is going to have pointers. You're not going to be dereferencing. You're not going to be universal references. You can write code that looks a lot like what you're used to look. I mean, it's basically C-like anyway.
Yeah,
There's
for
going
the
to be a
most-
couple more characters and
Yeah.
stuff like that, but
Yeah, for the most part, you want to see something that looks like you have value semantics.
That's right.
Return types, and it helps the compiler as well, the optimizer, to give you a better code gen because it has a better semantic information about what you're actually doing.
absolutely.
Example of that is when you have range 4, instead of saying for I equals 0, you can just say for auto x.
auto ref
vector.
x.
Yeah, ref.
Oh,
ref.
no,
Yeah.
man, not
I think another
ref, ref.
example is
So
at least one
minorities.
ref.
So the interesting thing here
Use
is
a lot
that
of value
usually
semantics there.
people
Yep.
get confused about the beginning and end. With range 4, by construction, it is correct. You cannot get out of bound. It is correct. And you get the efficient code gen, even in debug mode.
Yes.
Awesome. What is the status of work to compile C++ to ASM.js? None of you guys are
that-
working on that.
So we are not
are you?
working on it. We're not
Yeah.
working on it right now, but it is one of the ideas that we have only on the backlog, and
Okay.
at some point we'll get to it.
Great.
Coming up if you
Are inline variables something we can expect in the 2017 lifetime?
So we're targeting, and it's not a promise, but we're trying to be C++ 17 complete in calendar year 2017. So I would say possible. I have mentioned to the compiler team that there's an STL feature that requires inline variables, so I want them to prioritize that over other stuff. I mean, everybody's important, but the STL is the most important.
Of course.
As far as I'm concerned.
Oh, but of course.
So I would say likely, but it depends on their schedule, their prioritization, that sort of stuff.
So in the STL itself, one of the things I'm curious about, and I want to ask all of you this, like when you're cranking code and you're implementing the STL, are you using C++ 17 features?
Oh yeah. I'm
Meaning
using
compiler?
like the
Yes.
bleedingest edge features.
You're using the bleeding edge features, implementing the bleeding edge features in STL,
Yeah.
which makes sense.
The compiler itself
Yes.
is written in C++ 17 as implemented right now.
Okay.
So structure binding, they went in there.
Cody started using context for if
Yeah,
in the
context
compiler.
for if is as it is implemented. So this is its own dog food. We're eating our own dog food.
Excellent.
I want to make a comment on the inline variable
Yeah.
things. By the time we get modules, I hope very soon inline variables will not be important anymore. It's a stopgap measure, and I think we should be thinking in terms of what we want code to look like in 5 years. The reason I'm saying that is, I get this job, I'm writing code. At some point, I hope to be promoted, and someone else is going to take on my code, and I want that person to have an easier task than I did when I came in.
Excellent.
yeah.
Good. So we're running low on time. I want to do one thing. I did invite Kenny here because I want to talk about, like they did it. Today was the Windows Day at Build. It was Windows Day. And one of the things they talked about was building these UWP apps and being able to run across platforms and stuff. But for C++ developers, traditionally they've had to use the CX language extension because of some of the new Kami stuff that you guys have done. And I'm not going to crap all over that. Mario's right there. But I will say this. What you're promising with C++ WAC WinRT, which is standard C++ for the Windows runtime, is exactly that. I can write standard idiomatic C++, and it'll work in my UWP app using the built-in functionality and sort of stuff that you built. I want you to explain exactly in 2 sentences what you've done.
Well, so C++ WinRT is a language projection for standard C++. Interestingly, it's perhaps the only language projection that's written in the language that it's targeting, right? You know, you look at something like CX or C# and all these other ones, they're all written in something else. We've built C++ WinRT from the ground up with standard C++ using the latest cutting edge features of C++. Const exprs in there, everything else is there as it serves the needs of the language projection.
Mm-hmm.
And it really makes the connection between what we all love as standard C++ developers and the platform we want to target. You know, at some point it gets real, and you have a real machine with a real operating system that you want to write real code for, and you want it to light up and shine, and that's what we're going to do for you, as opposed to saying, well, you got to buy into this new language or this set of extensions or this fundamentally different programming model. Bring your existing desktop application, bring your existing C++ code, hash include some headers, off you go, build your app with targeting UWP.
Excellent. So you can take advantage of a lot of libraries and code you didn't write yourself.
Yeah.
Or you can bring your old stuff over. But I did have questions about that, because what if I'm using types that don't make sense in the Windows runtime world? In other words, how do I go? Isn't there still a boundary that I have to worry about?
Yeah, so that's some of the magic that C++ WinRT takes care of for you. We try to provide the most natural binding from standard C++ and STL types to WinRT. Now we have this ABI we have to deal with, but for example, if you have a std vector, you can pass it directly to an API call expecting an I vector, a WinRT interface that represents a collection. And we'll take care of things like lifetime and making sure that we present that std vector as the correct ABI type across the boundary. But you as the developer don't have to ever care about that. You just pass your types, your std wide string, whatever it might be, and it just works. One of the things we do, for example, is instead of dealing with date time and time span from WinRT, we just let you use std chrono, and it just works. So things like that, we make it as natural as we possibly can, and we do so in such a way where there's no runtime cost. Every feature we add, it's always compiled away.
Nice.
So this
I've seen graphs that show that apparently your wrapping of std vector is higher efficiency than my old collection.h from 2012.
Yeah.
It's pretty impressive, because I thought I was getting the minimal possible overhead, but you're doing even better.
Yeah, but the thing is, I'm standing on the shoulders of these giants who are building great tooling for standard C++. So as the compiler gets better at optimizing standard C++, I get to look better.
Great, man. And you're doing a real service, though, to the community out there who want to actually program in the language they want to program in.
Yes.
Yeah.
Versus something that's sort of like the language I want to program in, and it's just a thin wrapper and everything's going to work great. This is beautiful, man. So definitely want to give you props. I want to know who's using it. Like, is anybody, are you letting anyone use it internally that you talk about?
Well, so you can go to GitHub today. Anyone can go to GitHub and download the headers and use it to build an application. Yeah. There are many teams internally using it for various things. I can't tell you specifics. But
that's all I wanted to do.
Yeah, but certainly there are quite a number of teams that have adopted it internally. We're hoping to release the tooling itself, because right now you go to GitHub and you can download the headers. But ultimately we want to say, here's the tools that you can generate your own headers based on a certain platform SDK, or if you want to author complete organic types yourself, here's the tooling you can use to do so with standard modern C++.
Excellent. That is definitely rock and roll. So I believe we're running out of time. Is that time correct? We're really running out of time. Actually, it keeps going up. I like that. So no, we're increasing in time. Oh, man. I wish we had an hour, man, but we don't. So we have to talk again. You guys have to keep coming back to these events. And you need to
Pleasure.
get more of you guys on Channel 9.
Sure.
And start talking a bit more what you're doing with demos and samples, how people are using it. Really interested in what's going to go on with modules. That's going to make people happy.
With pleasure.
People asking for it. You guys are doing amazing work in the IDE and sort of that tool chain, STL and STL. We didn't get to all of the C++ 17 features you implement.
No, it's actually not me
I thought you
anymore.
were the one who's implementing it.
Oh no, we've got a whole team of library developers now working on the
What?
STL. That's something I think that people haven't really appreciated because
No, I had no idea.
Yeah, we've really staffed up the team to get CS+ 14 and 17 conformance. We've got.
So do we still call you STL?
Oh yeah, I'm still STL. They're not renaming me.
All right, man. Thank you, guys.
Did everybody notice Charles' T-shirt?
Oh.
Great choice of
Oh.
T-shirt
Old
today. I
school,
really
brother.
love it.
Old
Thank
school,
you.
man. It still has some of his code on the back.
It's great.
Thank you, man.
Thanks.
Thank you.